and this is my lab 4 on oscillations. So for the introduction, the purpose of this experiment was to understand and identify the motion of a spring mass system while the mass was oscillating. So the goal was to determine whether the model follows the energy principle. For this lab, I used Tracker for the observed position and GlowScript for the computational model. So our results had a total energy remained constant at 0, and we used the energy principle. So the three fundamental principles were Newton's second law, which states the acceleration of an object is directly proportional to the net force acting on it, and it's inversely proportional to its mass. The energy principle, which states energy can neither be created nor destroyed, and then the updated formulas of Newton's second law. So here's Newton's second law, which is F net delta P over delta T. We have the energy principle, which is energy of the system equals work of surroundings. And then we have the updated formulas. For system and surroundings, our system was the mass, spring, and earth, and then our surroundings was nothing. So for the first part, we have our observed motion, which was done on Tracker. And this video was used and then tracked on Tracker to get this graph here. So we have our object mass of 0.402. We have our initial length of 0.70 meters, our initial position here, and then our initial velocity is 0. For our initial conditions, we use the graph given by Tracker to solve for relaxed length, which is going to be 0.127 meters. We solved for t using this equation to get 1.519 seconds. And then we solved for the spring stiffness, which was going to be 6.878. So then we use the computational model on GlowScript. So our initial conditions we took from our other model, and our mass is the same here. We put in our initial position vector, and then again our velocity was 0. Then we put in here our relaxed length that we calculated for, and then our initial length that we calculated for. Our spring length and system energy was plugged into our code here, and then we calculated the gravitational force, the spring force, and then the net force. And then we applied the momentum principles, and we updated the spring length and position. So for comparison, here are the two graphs. So some possible errors include the system not being isolated from the surroundings. So this means there'd be more work done from the surroundings that was not accounted for. There could also be an inaccurate center of mass placement on Tracker. Is an energy principle satisfied? Yes, since there's no external force affected the isolated system, the change in energy is 0, and the graph shows a total change in energy here, which is 0. Our delta E is the orange, and the line is flat. So comparing the oscillation periods, in the x direction, we solved this earlier, and we just used our data from Tracker. And so we got in our x direction 6.878, and then in our y direction we got 6.130.